So, nice, it's a full house. There are still seats available at the front here, so if you want to sit down, go ahead. I'm just going to get started in the meantime. Today we're going to talk about the combination of Dapr and .NET Aspire. Well, you all have seen the keynote this morning about Aspire. It's a very nice technology to use, but there is much more you can do, especially when you combine it with Dapr. So that's what we are going to talk about this afternoon. It's nice to have you all here, especially because it's the biggest audience I've had since ever. So it's very nice to have you all here. I'm honored to have you your time. Bit of introduction. My name is Florian van Dillen. I work at 4.net. We do .NET consultancy, Azure consultancy, and in that aspect I am working with a customer of mine, and we actually build Azure container apps. We use Dapr in production actually there already. So yeah, we are actively working on those technologies right now. This is one of the aspects that I really like about .NET and Azure, especially when you build systems that are distributed. Well, they introduce a whole lot of new complexity that you didn't have before, and I like that. I like scaling up stuff, making sure things talk to each other. I get real happy when I get to use that. So without further ado, distributed applications. So building those can be hard. When you build them, you introduce a whole lot of new complexity. And the first thing that you might feel some pain about is when they need to talk to each other. So communication between distributed applications can be synchronous, can be asynchronous, and when they have synchronous communication, well, one service needs to talk to the other, so it needs to know how to talk to the next service. So it needs to find out about the host name, which methods should it use. So that's one of the issues that you get. And then you have asynchronous communication. Well, how do they communicate? Which topics? Which message broker? So you get a whole lot of different complexity that's being introduced. Then you have, well, this guy is building something, he needs to configure something. How do you get your configuration? Because when you have multiple applications, you suddenly need multiple types of configuration. What about when you have 10 instances of your containerized application running? Because it's scaled up, it still needs, all the instances still need the configuration. So what happens when the configuration changes? You have to reload it. What do you do? Well, then there is the question of data. So your application uses data, it has a state of some kind, so it needs to sometimes look up the state, it needs to save the state, it needs to keep track of what it's doing. So how do you do that? Especially when you have multiple applications running in conjunction, and they all need to keep track of their own little bit of state. So how do you do that? And then there is another topic, observability. So when you run an entire landscape of distributed applications, how do you keep track of what they're doing? So something happens in A, it needs to talk to service B. So I actually want to see the entire chain of events from A to B to be in the know about what's happening. So that's another thing that's, well, can be hard to configure it all, to get it all working together, and to see what's going on. And then there's your development environment. So when you work as a developer locally on your local host, you might have different services, you might want to run them together, you might only be working on a single one. So how do you build a good local development environment in which you're not especially dependent on all sorts of cloud services? So you might need to contact cloud services when you're developing locally. You actually don't want it. You want to keep it on your local host and you want to be working locally. Well, and when you push your application to the cloud, it should still work without any modification to the code. So I've prepared a little demo application today for you, and it demonstrates what the different types of communication are, how they interact with each other, and how you can see what's going on. So there's a little conceptual model that I made. The reason I made this with the topic of aircraft is because I live right next to Schiphol. I can barely touch the airplanes when they're landing next to my house. So, well, here we are. So I have 3 services today. One of them is called Flight, and the responsibility of the flight service is to dispatch scheduled flights that are taking place. And each flight has a time of departure, has a destination, and has a type of aircraft that it's using for the flight. And then there's the airport, and of course the airport is responsible for facilitating the flight. So it has the runways, and it will allow the flight to take place. And then there is this this guy here is the regulatory inspector, because all the neighbors of the airport, of course, are very critical about all the noise that they're making. So the inspector is responsible for making sure the airport is not open between the hours of 10 in the evening and 7 in the morning. And it also is very picky about the amount of big airplanes that are passing by in any 30-minute window. So if there are more than 5 in a 30-minute window, well, a violation is recorded, so to say. So this is the playing field that we're going to explore today, and with this example I'm going to show you how it all works. So first of all, I'm going to talk about Dapr, and later I'm going to talk about Aspire. Important to know is that you can use one or the other or both. It's completely optional. You don't have to use any of them. So if you just want to use Dapr, fine by me. You're good to go. So what is Dapr? It's a set of APIs, building blocks to build secure and reliable microservices. So it offers you, well, sort of abstraction of your infrastructure. So you don't have to use a Service Bus SDK in your code. No, you can just talk to the Dapr client, and the Dapr client will know how to communicate with a Service Bus or any other message broker that it supports. And that's just one of the flavors of building blocks that you have. I'm going to go over all of them in a second. So what is it? When you have to describe it in one sentence, it's the glue between your services. And it can be microservices, it can be distributed monoliths, it can be anything, but well, it's a little bit oriented towards microservices, but they don't have to be. The goals of Dapr provide an integrated set of APIs. So again, you have all the different building blocks, all the different flavors. You've got PubSub, State Store. It provides that for you, and all your code has to know about are these building blocks. Your code is not aware of what the specific Service Bus implementation is, or if you want to go to Redis or Cosmos, it doesn't care about that. So locally, you can do something entirely different than in the cloud. Also, any language or framework. So we are here at a Microsoft conference. We all do .NET probably, but you're good to go with Java, PHP, Python. As long as it supports HTTP, you can talk to a Dapr sidecar. So yeah, any language or framework. It doesn't force you to use .NET in any way. Then best practices and standards. Well, it's all good to have those, right? And platform agnostic. So it doesn't care about you using AWS, doesn't care about you using Azure. It provides flexibility for you to use any type of platform. If you want to self-host it, if you want to use a managed service or something in between, yeah, it supports that. Then it's extensible and pluggable. So if a Dapr component is not available in the flavor that you'd like, you can basically create it if you want to. There's a lot of community created components as well. So as the community grows, well, that's the last goal, of course, community-driven, vendor-neutral. It's a lot of community support. If something's not supported right now, it might be in the near future because the community actually provides that for you. Excuse me. How does the Dapr architecture look? So I mentioned a sidecar. So what is a sidecar? Imagine your application. Your app is just one of the services in the entire thing that I just showed you. When it launches, you actually launch a Dapr sidecar as well. So it's just a process. Can also be a Docker container, but and when you're working locally, usually it is a process that you launch. And those two communicate with each other. So your application communicates with this Dapr sidecar and it receives responses back and it's able to process that. So I mentioned state, I mentioned pub/sub. These are just HTTP requests. So if you would have no language support at all, if you didn't have any .NET SDK, which we have luckily, you could still fire off these requests and you would still be able to communicate with a Dapr sidecar. So it's that flexible. You're not, we're free to use any language we like. If there is no SDK for your programming language that you're using, you can still use this. But then again, there is great .NET support, which I'm going to show you in a second. So this is actually the entire thing. How you launch the sidecar is up to you. There's I'm going to show you a few different ways in which you can do it in a second. But every app that you have has a sidecar. So if you have multiple applications, in our case we do 3 different services, we also have 3 different sidecars. And the sidecars are able to communicate with each other, which is well, it creates kind of a service mesh, it's a sort of. So this is how the architecture looks. And if you look at the bigger picture, this is how it all ties together. So you actually are able to use any code, any framework, whatever you like. And the code is just able to use the HTTP or gRPC APIs. It's able to use one of the building blocks that Dapr offers. Dapr also offers some observability, security, and resiliency. Also going to get there in a second. And it runs anywhere you want because it's a vendor neutral. So the components. So the building blocks of Dapr are basically divided into different categories. So you have different components that fall in a specific category. So I mentioned state stores, which are able to store data. So basically key value, you have some kind of application state. Let's say the airport is open or closed, and you can save that state into a state store component. So it comes in different flavors. By default, you have Redis, can go to Cosmos DB or any other flavor that it supports. And the same goes for pub/sub. So you can do Redis or Service Bus or RabbitMQ, anything you like. And then there's others, like secret stores. You can actually get secrets from a supported store. And the same goes for configuration. So you pull configuration values from a configuration component. And there are also others. Distributed locking is a nice mechanism for when you have multiple instances of your application and you can only want to do one connection to something external, for example, that has rate limits or something like that. You can use the distributed lock to prevent one service from overtaking the other, so to say. And then there is workflow and also actors. There's a nice session in the next session as well for Mark Duiker. He will be able to tell you all about the Dapr actor model. It's a really nice component-driven way to, well, scale things up, so to say. I'm not going to go there. I'm just going to go with creating our local development environment. The great thing about these components is that you can actually swap them. Yeah, we're going well. So, for example, when you use Azure, your application might use the key vault. So your sidecar is able to interface with the key vault, and it's able to pull configuration values into your application via the sidecar. And then it publishes a message, an event via the pub/sub component, which in this case refers to Azure Service Bus. Then the next application processes that message, and another also processes that message, which then saves state in Azure Cosmos DB. And the great thing about this is your application only knows about, in this case, a secret store component a pub/sub component and a state store component. So your application code only refers to the components. And as you change your infrastructure, let's say we move to AWS, the implementations of these components actually changes, but your code doesn't. So your code still only uses secret store, pub/sub, state store, and under the hood, it connects to a different thing. And this is how you build applications with Dapr. I'm going to show you how you configure a component in a second, so it makes a little bit more sense. But this is the bigger picture. It's interchangeable, it's swappable. Then there is resiliency. So what happens when you publish an event from your application, but it doesn't work? What then? So Dapr has the ability to actually configure the behavior that you want when something goes wrong. So instead of just failing and you see a big red square in your logging somewhere, you can actually configure it to retry sending a message or retry receiving something from the state. So this is quite important, quite nice actually, because it allows you to precisely configure the behavior that you want, indefinite retries or exponential backoff. These are really nice things to make your applications so much more resilient when you're using them. And you can selectively apply these two components. So if you have one specific thing that's buggy or laggy or it fails a lot, you can actually create a resiliency policy for that specific Dapr component, and you will be able to make sure, well, it retries or retries for 10 minutes. You can configure that using the provided YAML. This is an example of such a resiliency policy. So what you see is actually, you give it a name here, has a scope, so you can actually scope it to a specific application in your application landscape. And then you can configure the policy with timeouts, retries, or actually retry forever. Well, you can choose how your application should respond to failure. So this is actually quite nice. You can go really far with this. And I do actually use this in production as well. It works really well. This brings me to the next topic, which is observability. So it's important to see what's going on, what's happening in a distributed application. So Dapr has built-in telemetry, which it produces, and by default it goes to one of the provided telemetry tools, but you can use this in a bigger aspect. It's all OpenTelemetry, it's all standards-based. So the target where you configure it to send its telemetry, it will just send it to. So, well, you're able to combine that with the application telemetry that you're producing. So when you have a landscape with multiple applications running, the sidecars all produce tracing information to the monitoring tool that you configure. And as long as that monitoring tool accepts OpenTelemetry, you're good to go. And you can see and follow along sorry, what's happening in all the different sidecars. And it's especially powerful when you combine that with your application sending in telemetry as well. Because when you receive that in one monitoring tool, you can actually combine that and get a complete view of what's going on in your application. I've included that in the demo, so we'll get to that in a second. But this is one of the important aspects. You want to see what's going on from A to Z, especially as your flow in the application goes over your different services. Then we have hosting modes in Dapr. So again, we're not vendor specific. We can host anywhere that we like. So we have different types of hosting, the sidecars as well. So the most simple thing when you install it on your machine, Dapr, you install the CLI and you type Dapr init. So Dapr init creates a set of containers on your local machine that support Dapr. One of the containers is Dapr Redis, which supports a out-of-the-box state store and out-of-the-box pub/sub component, which you can use to develop your applications. It also comes with Dapr Zipkin, which is the observability tool that comes out of the box. Just a Docker container, you can click the endpoint of the Docker container and you will see what's going on. So this is just how you do the self-hosted stuff. I will show you with a demo in a second. Then there's the virtual physical machines, so you can actually install the control plane on a VM and you're good to go as well. Again, you use the Dapr run command to launch it. Dapr also runs in Kubernetes, so you can actually initialize Dapr in a Kubernetes cluster, and you will be able to it injects the sidecars for you. So you don't have to launch the sidecars yourself. You just annotate a container and it will fix that for you. It will inject itself. And then there's serverless. There's multiple offerings right now where you can actually just get the sidecar hosted for you and just give it the settings that you want, and you'll be able to use them from your application. You just give it the address of where it is, and you're good to go. This way, you only have to manage your applications. So it's really nice. It's not for everyone. If you want more control, this is probably not for you, but well, it does the job just fine. I'm going to skip this one. I just talked about it. You have Docker. You need Docker. Need the Dapr CLI installed, and then you do Dapr init in your command line. Then there is Azure Container Apps. It's really nice. It's one of those more serverless offerings of Dapr. You just need a Azure Container Apps environment, and then you can define your Dapr components with Bicep, and then you just create them as you go along. You don't have to create any sidecar. You just enable Dapr on your container app, and it will inject itself into your application. So that's pretty nice, pretty powerful, and we use it in production as well. I'm just going to go and run a Dapr app because there's a lot of theory for now. It's actually nice to see what's going on. Just gonna. There we go. Okay, so I want to introduce you to the airport service, the first one. And the airport service is actually a pretty simple web API. Yeah, I can certainly make it even bigger. Is this all right? Yeah, I'm good. So this is the airport service, and the airport service is actually fairly simple. It's just a web API. It's configured already with Aspire. I'll get to that in a sec. But this is where all the services are injected into the service builder. And the important thing is that the airport service has a controller that processes events for when flights are scheduled, and we have a status controller which enables us to check the status, so we can get the status from the airport if it's open or closed. And then we have a open endpoint and we have a closed endpoint. And all it does is just saves the state of the open or closed state of the airport. And as we can see here, we inject the Dapr client here. And the Dapr client is what we use to interface with the Dapr sidecar. So this results in fairly simple calls to stuff like get state async. And all we have to do is tell it which state store it should fetch the value from and which key it should fetch from that state store. And then when we actually set a state, this is also the same. We say which store do we want to save the state to, what key do we want to set, and which value do we want to write to the state store. And then of course you also see a publish. So we publish to a component called pubsub, and it's a topic airport status changed, and then we give it an event. We just send it some data. So this is pretty nice, but how does it work? So when we when launch a Dapr sidecar, what it needs is a configuration. So it starts to look for configuration. And when by default you do Dapr init on your install system, you actually get some of these components for free. I just mentioned the default Dapr container, or the Redis container, where the state store and the pub/sub is housed. These are the two that you get for free. So you have a pub/sub and a state store component out of the box. You don't have to do anything for that. If you look at the configuration, this is what you get. So you get a pub/sub component called pub/sub, and it's of type pub/sub Redis, and it just connects to the provided container by Dapr. You get it out of the box, just a local host, Redis host. And the same goes for the state store. So it connects to the same Redis host. This is pretty nice because out of the box, these are loaded. In our example, I actually load these specifically from the project. My bad. So the project has these included. So I actually point it to my specific folder, so you can actually put these component definitions into Git as well. But if you don't specify which folder you need, you can it'll just fetch them from your user profile. So just something to take into account. So how do you launch a .NET application with Dapr? If you go into the folder where your application is, and I'm going to make it a little bit bigger. Yeah. Let me just get the correct one. Yeah, that one. So you have the command in the Dapr CLI called dapr run. And when you run a command like this, what you need is an app ID. So you actually assign a unique ID to your application that you're going to run. In this case, it's airport. And you configure the ports, and you, at the very end, if you look, you'll see .NET run. So I basically launch the Dapr sidecar from the command line first, and then I do .NET run. So since I'm in my project folder, this is what happens. So you see the output of the Dapr sidecar and the .NET application together. So they now run in the same process. And it's nice, you can actually do this. You can actually connect this in your CL or in your IDE. You can press F5, it will launch this process and it'll work together. But it doesn't actually attach a debugger or anything. So, well, the use of this is actually quite limited. I'm not using this at the moment. So you want something different. You want something better. So how can we make this better? There we go. The clicky thing is not clicking. Nice. Okay. I'm going to introduce you the Dapr Sidekick. Okay, what is the Dapr Sidekick? As I mentioned, I don't want to do Dapr run in a command line or in an IDE and then not have my debugger attached. So how can we solve this? Well, there's a very nice NuGet package called the Dapr Sidekick, and you install this in your project. And when your project starts, you can actually instruct it to create the sidecar for you from your code. So your code is already attached to the debugger, and then you instruct your code to create the Dapr sidecar. And actually, I'm going to do that right now. Just copying the code. There we go. Should be able to see it now. Yeah, there we go. Okay, so I'm going to go to the program CS of my project, and I want my Dapr Sidekick to run. Ah, nice. Completely messed it up. Wow. Just gonna. We need, this is what we need to do. We say add Dapr sidekick, and then we give it some options. There we go. Just copying the code again. Options.sidecar. Yeah, okay. Then we need to assign it the app ID. So in this case, it's airport. So when we go back to our terminal now, where we ended the Dapr run that we just did, we can now do .NET run just to demonstrate it. It'll do the exact same thing, but now the .NET application starts up first. And it is now the responsibility of the .NET application to launch its own sidecar. And you can see that we actually created it. It's the app is already subscribed to the topics. So this is pretty cool, because now we can actually do stuff with the application. We can run one application, or we can run all three if we define that in our IDE. So this is pretty powerful, but we're still not there, because we actually want a little bit better environment, because we want to orchestrate all the stuff happening together, and we actually want to see what's going on. Small little thing in between. You can actually publish events to a pub/sub component with Dapr from your CLI. So it's pretty cool. You can actually see that here. Just do Dapr publish, can say which pub/sub component it should go to, which topic it should publish a message to, and which ID we are. So in this case, we're the flight service, and we produce a flight. So if I... yeah, well, you can do that. Just gonna skip it for now. Yeah, well, you can send events from the command line to debug your applications. But we want to level up this stuff, because well, we have we can run with the containers, can see what's going on, we can log stuff, but we need more visibility into what's happening. And this is actually where Aspire comes around the corner, because you actually can orchestrate the entire local development environment with Aspire. You can run multiple services quite easily. You can spin up extra containers that you need. And you can quite deep, actually, can see a lot of the telemetry that's going on. You can actually click through the telemetry. You can filter it. You can see it, what's going on. So this is really powerful, and I'm going to show you in a second how that looks. So the Aspire dashboard, it shows all the metrics and traces that you have, all the logging, all the configuration of all the different services that are running on your local machine, but also any other containers that you might start. So you're not limited to your projects. You can also spin up SQL Server and that kind of stuff. So there's two big parts in Aspire that are important. These are the service defaults. This is something that you get with the Aspire template. It's an opinionated startup, so it configures your application to use OpenTelemetry, all the default health checks, all the default endpoints. All that comes out of the box. So the little screenshot that you see actually configures how the API Explorer works, how Swagger is generated, the Dapr client is added. I think this is something that I added, actually, but out of the box, all this stuff is already done for you. So this is important. So the app host, this is a project that is generated when you do Aspire. You get the service defaults and the app host is the actual thing that you're running. So when you press run in your IDE, it goes to the app host, and the app host is actually the thing that starts up, and it starts up all the other applications as well. And this is how we now launch the Dapr sidecar. going to show you in a sec. So you don't actually have to use the sidekick anymore. Now we just have Aspire, and Aspire will run as our sidekick. It's quite nice. So we have a little demo of the Aspire dashboard. Yeah, I'm going to skip that for now because we'll be in there in a second anyway. I'm going to start it up for now. I am going to go there. There we go. I'm going to close this process. So of course the sidekick is no longer needed, so I'm going to comment that out. We don't need that. And as you can see, my configuration here actually launches the app host. So it just runs the app host, will go there. And while it launches, I'm going to show you the code that's being run. So the app host here actually has a distributed application builder. This is what you talk to configure your local environment. And we add Dapr to that. So we add Dapr support to the Aspire host. And then we can actually add projects. So we can actually add the airport service here, and we give it the airport name. So now it's called airport. And we tell it to add the Dapr sidecar for us. So this now launches our project, so it launches our .NET application, and it attaches the Dapr sidecar to it. Then what we do is we actually give it the Dapr component directory that's in our project, so we can actually put our Dapr component configurations inside of version control, so we can distribute them to other developers as we go. This is quite nice, so now we don't have to copy and paste all the Dapr component configurations to each developer. This is just nice for reusability. Then there's a SQL server that we use to support the regulatory inspector. It records violations inside of the code, and it puts them inside the SQL server. We put it in the variable here, and then we reference that. So it knows how to connect to the SQL server. And this also goes for the flight service. So it's just a project with a Dapr sidecar. I'm going to switch to the... yeah, there we go. So this is how it looks. This is a top-down view of everything that's going on. So what we see is on the top, we see the SQL containers running. So it's actually a Docker container that it spun up. We can see the logs of the Docker container. You can see that it creates the database for us every time it runs. It creates 3 Dapr sidecars that are communicating together. And it creates 3 processes with the airport and the flight and the inspector that is being run. Okay, so we can dive into the logs of any of those things. So we can just see the flight service. I think we can actually see that it's found out the airport is open, scheduling the flights. It's an A380 to New York. And the nice thing is it does this every few seconds. And how it does this is by using another type of Dapr component, which is the cron component. So this is just one of those flavors of components. You create it, you actually scope it to the flight service. So only the flight service loads this component. So the Dapr sidecar of the flight service loads up the cron component and is then configured to basically fire off an HTTP request every 20 seconds. And we have the endpoint in the flight service to schedule a flight. So it's randomly selecting a aircraft type and a destination, and it will then publish a flight scheduled event, which is then handled by the inspector and is then handled by the airport service to actually keep track of what's going on. So this is quite nice, but what about structured logging? Well, sure, we have structured logging available. And the nice thing is that this actually shows us logs from all the services in one overview. So you can see the flight service is doing something, then the inspector is doing something, then the airport is doing something. So we can actually filter and we'll see what's going on with all the stuff here. But to take that to an even higher level is the tracing screen. So all the OpenTelemetry is collected by Aspire, and it will be able to do, when you do stuff, starting with a request, it publishes an event, and then it checks the state, and then it writes to the state. This is all recorded in one overview from A to Z in one activity. So you can actually go into the details of each and every activity that's going on, and see where it came from, what it's doing. And then when you see something that's odd or something you might want to inspect, this is one of the most useful features I think is in Aspire right now. So that you can actually go to the top right here, you can view the log. So you can actually go from a telemetry to the structured logging again. And then you also see the associated trace here. You can actually see that it's filtering on that property here as well. So you can actually go into one specific occurrence of something, and you can actually see what's going on there. And you even see the command it executed with entity framework to store the violation, because, well, apparently more than 5 big airplanes were scheduled. So that's a problem. Then there's metrics. As you can see, we actually created custom metrics here, and I think that's a very powerful feature that too little people are currently using. You can create custom metrics in your code, and you can register them with the OpenTelemetry software, the SDK in your code, to actually be sent to whatever target you define as being the OpenTelemetry endpoint. So every time a flight is scheduled, actually see it here in the airport controller, or the airport service where we inject the metrics class that we created. We actually call that flight scheduled method. And this class is registered with OpenTelemetry config in the program CS. We actually registered it as being, hey, we want to send these metrics to whatever you configured as OpenTelemetry. This is being sent. It's being picked up because we gave it a name. And then when we go here into the metric screen, we actually see it. So this is very powerful. We can actually analyze what's going on with our application. And it's especially handy when you have distributed applications there where multiple applications are talking to each other, communicating with each other, and they have to reason over, well, what's going on, who's right. So yeah, I think this is really powerful. I know I've skipped over too much stuff for my liking, but I saw the time coming closer. And I do want to give you guys a chance to well, ask some questions as well. So please do, if you have them, raise your hand. I'm sure you'll have them. Go ahead.
I already have one, sorry.
Nice.
It might be a bit of a bummer, but what are the cons of using Dapr? So we already heard the pros.
Yeah, okay. So what are the cons of using Dapr? Well, there are a few. Well, I started the presentation with, okay, building distributed applications is hard. It's not perfect. I mean, you introduce complexity because now suddenly your applications are divided. Well, there happens something here. We need to know about it there. How do you do that? So how do you keep track of like what the events are? Who keeps track of what the event classes should look like? That sort of stuff. So that's quite hard to actually get right. So that's one. So it's not without complexity. I think that's the most important thing. And that's not specific to Dapr. I mean, it's specific to distributed applications in general. Well, you have to learn. Not everyone understands right away how the sidecar works. So yeah, there's some knowledge involved as well. So.
Hosting, because you need to host in your pod separately a different container for every sidecar, right?
Yeah. So if you use AKS. Yeah, it could, of course, yeah. So in Azure Container Apps, it's quite simple to host it. I mean, you just enable Dapr on a container and it will inject it by itself. And if you use AKS, you actually need to you have to inject the Dapr stuff in your AKS cluster. So yeah, there is some complexity involved. It tries to make the life of a developer easier, but it's not without risk, of course. Yeah.
You're also vendor kind of locked with your code, right? Because you don't use HTTP clients and no like SDKs. You use Dapr everything. If you want to.
Yeah, under the hood, it's HTTP. So if you really want, you can still issue those HTTP calls to the Dapr sidecar. But well, yeah, there is some extra abstraction involved. Yes. Yeah. And what's good to know is that you actually, when you do Dapr invoke, so when you directly call one service from the other, you can actually get the HTTP client with the correct hostname configured from the Dapr client. So it will actually spit out an HTTP client, and you can still use that. So if that's what you want, they did think about stuff like that, luckily. Any other questions? Okay. That's nice. I did include a QR code to the repository that I used. Do want to share a pro tip with you. There is a nice .NET Aspire plugin for Rider. So if you use that, it will actually attach the debugger to all the projects automatically. If you don't use that, you have to do it by yourself. Shows trace diagrams, shows metrics in Rider. So if that's your thing, I can recommend this plugin as well. When you use Aspire, there is a big important pitfall to avoid. It's in preview, so you get a lot of preview versions for Aspire. If you install Aspire, you do that with the .NET workload command. Make sure that version that you install with the .NET workload command is the same as the version you use with the NuGet packages. If you update the NuGet and you forget to update the workload version, you're fucked. I can't put it in any different. It will not tell you. It will just give the weirdest output, the weirdest errors that possible in your console. I'm sorry. Make sure that your versions are correct, because it will save you some pain. I would wanted to know earlier, if possible, and ensure Docker is running, because the amount of times I forgot to launch Docker and run into issues where things wouldn't launch, will save you some time. I'm going to share the QR code now. Oh, that's a current slide. Oh, nice. Oh, there we go. If you have any questions about the code, feel free to reach out. Feel free to open an issue in the GitHub repo. I'll be happy to help you along, answer any questions you might have. Well, all that rests me is thank you for your time. I am honored that you are here, willing to listen to what I had to say. And I wish you a very nice day. Thank you.